Okay, so here's the video to accompany section 4.4 in the textbook. And this is the section that deals with Newton's third law. So let's take a look at this using the whiteboard. Okay. So Newton's third law is fairly straightforward to state. I can state this in very simple terms. These are not the terms they use in the book. These are my terms, but it means the same thing. So Newton's third law, Newton 3, says that forces always come in equal and opposite pairs. And that's pretty much it. So what does that mean? What it means is that if let's say you have two systems, okay? So let's suppose you have one person here, okay, just standing there, minding their own business. And then you've got another person who comes over and pushes on them really hard. Okay. So here's a large person and a smaller person, and the smaller person is pushing really hard on the large person. Well, this person here, you know, is just minding their own business, and they don't even see the smaller person coming along. And so this smaller person comes up real quick and pushes as hard as they can on the bigger person. Well, basically what Newton's third law says is that when this person, let's call them person A, when person A pushes on person B, right, this is person A, this is person B. When person A pushes on person B pushes back on person A just as hard, whether person B wants this to happen or not, okay? So what we have is, we have a force that's exerted by person A onto person B. Well, person B is going to push back onto person A with exactly the same magnitude of force. It'll just be exactly in the opposite direction. Okay, and this happens no matter, you know, who's in control or not. You know, you always, anytime there's a force, you always get an equal and opposite counter force. And you get that for free. That's just going to happen. Now, you might think that, well, how come these forces don't just cancel each other and nothing ever happens, right? I mean, imagine if, you know, these folks were on roller skates, right? And this one was just standing here, and then this one came over and pushed really hard. Well, you know, if they're really good roller skates and it's a nice, smooth, even track that they're on, this person may just begin to roll away. They'll accelerate away after being pushed on by this person. Okay, and so we know that the force on this person wasn't canceled because it resulted in acceleration, right? There was a net force, and this person accelerated away. What also happens, by the way, if they both have on roller skates, when this one pushes on this one may accelerate away, but this one will also accelerate away back the other way. Okay, and if this one is much bigger than this one, the smaller person may actually accelerate away faster than the bigger person does. So how can they both experience accelerations if there's equal and opposite forces acting here? Why don't they just cancel and then nothing happens? The reason is because each force is acting on a different system. So force A is acting on system B, and force B is acting on system A. And so they will, they'll each experience their own accelerations because they have different masses. And they each experience an unbalanced force. Okay, so that's basically it. Newton's third law says that anytime you have a force of any kind, there's going to be an equal and opposite force in the opposite direction, an equal and opposite force that opposes or doesn't oppose, but just points in the opposite direction that act back on the system that's initiating the force in the first place. So that is Newton's third law.